Hi everyone, today I continue as usual solving problems on Leetcode. Yesterday I solved how the name is, find all groups of farmland. It was the daily challenge. I didn't manage to solve it by myself, so I just took someone's solution and that's it. Today, before the video, I solved it by myself. I tried to I just removed the solution and wrote it by myself. Also, I realized my mistake in understanding the description. I thought that farmlands could be only squares, but while I made my own solution, I realized that farmlands are rectangular areas, not square only areas. I even sent feedback that they have an issue, but it was a mistake. I tried to invent, discover, or optimize the solution, but I didn't manage. I didn't get success. My optimization is have to occupy hash map where I put occupied lines, or sorry, what is this, lines, segments, segments in each row, like I have like that. In the zeroth row I have occupied segment from 3 to 3. In the first I don't have anything. In the second is from 0 to 2 and from 4 to 4, etc. And I it's the same with other participants, other users' solution. I just remember where I don't need to watch if I see one in while I traversing the matrix. So I see the one and I check if it is occupied or not. If it's not, I understand that it is the new farmland, and that's it. But I also realized that replacing the values, the ones by zeros, in after when I found them here would be more efficient than my approach. And we can see it here because I have low memory usage, but I have a huge runtime. Let's try it again. Probably we will have changed some changes, yes, but not significant. So my runtime is not best. Okay, today I'm going to try the greedy algorithm. I already read some theory about greedy algorithms, and that today I'm going to not deep dive in theory and just start to solve. Here is the steps. I even didn't watch any examples. Just here's the greedy, some task. I have solved one of the problems. If it's easy, longest palindrome, I think I can try to solve it using greedy algorithm. Given a string S, which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. We have A, B, C, 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 D, D. One longest palindrome that can be built is DCC, A, C, C, D, whose length is 7. How can I apply greedy algorithm here? I need to watch some example, but without on array, operating system, graph, and complete special cases, but without my problem. Easy problems and into maximum composite numbers. Let's watch this example. Now given n, print the maximum number of composite numbers that sum up to n. First few composite numbers are 4, 6, 8, 9, 12. Oh, I see what is composite numbers. Max that sum up to n. Maximum number of composite numbers it means that we need less numbers. Start from the left. Okay. But why 2? 2 is not. 2, 3 is not composite. Okay. Some observations. Less than 4, it won't have any combinations. If the number 5, 7, it won't have any splitting. Since smallest composite number is 4, it makes sense to use maximum number of 4. Maximum number of 4s for numbers that don't leave a composite remainder when divided by 4, we do following. If remainder is 1, we subtract 9 from it to get the number which is perfectly divisible by 4. For numbers that don't leave a composite remainder when divided by 4, we do following. But we make sums. We can repeat these numbers, yes. 90, I need to watch an example. If we add 21 fourths, then we get 84, and then add 6 to it, and we get 90. I see, we can repeat 4. I see, for numbers that don't leave a composite remainder when divided by 4, we do following. If remainder is 1, we subtract 9 from it to get the number which is perfectly divisible by 4. If remainder is 1, for example, let's say 81. If we divide it by 4, it's equal to 20, and remainder is 1. We subtract 9 from 81 and get 72. From 72 divisible by 4. After what we do after it, 74. We got 74 divided by 4 and plus 9. I see. Main observation is to make n such that it is composed of maximum number of 4s, and the remaining can be made up by 6 and 9. We won't need composite numbers more than that, as the composite numbers above 9 can be made up 4, 6 and 9. Below is implementation. Example, let n90 count and if n less than 4, it's an edge case. Remainder. If remainder is 0, it's perfectly divisible, and we return n divided by 4. If remainder is 1, if n less than 9, return minus 1. That is 5. Okay, if the number is greater than 8 and has a remainder of 1, then express n as n minus 9 and it's perfectly divisible by 9 and 4 by 4 and for 9 count 1. For example, if it is 9 itself, so we return 0 for 9. 9 minus 9 is 0. We return 0. If the number is greater than 8 and has a remainder of 1, then express n as n minus 9. Okay, if number 5, 7, 11, it won't have any splitting. For numbers blah blah blah. Anyway, let's watch other numbers. If remainder equals to return n minus 6 divided by 4 plus 1 when remainder is 2, just subtract 6 from n when remainder is 2. Just subtract 6 from n. Remainder is 2, can be 6 or 8 or 10. Let's take 16 for the start. 16 minus 6 is 10, divided by 4. I guess. If divided by 4, we skipped it already. 8, so 8, 12, 16 is, we don't have it. And it's only 10, 14, 6 itself. Let's take 14. 14 minus 6 is 8, divided by 4 is 2, plus 1 is 3. 14. What will be 14? It is 4 plus 6. I see. But what if is 6? Then is 0. Okay, I got the solution. I guess I can, but why it's greedy? Do we have any explanation? It's some advertisement. Anyway, let's try it. So, which observation can we make? First of all, in the palindrome, the letter in the start has a pair in the end. In the letter in the whole first left side of the word has its pair on the other side of the word. So every letter should have should have should be paired. How can we use it? Except one letter can be in the middle, which does not have any pair. I think if it's greedy or not algorithm. It sounds like just direct approach. How can I check if the letter has its pair or not? I go through the string. I have I have some stack maybe where I push. No, I can't push there. I can't push there the number. I can't push it, but I can have map where I put the amount of every number in the string, but not amount. I just need to need to be sure that has it a pair or not. So for example, for C, I don't, sorry, I missed it. I need to return longest length of the longest palindrome. I don't need to check if it's palindrome or not. So I need to, but the approach is the same. I just need to drop any paired letters, and there will be no, I need to count their amount, their amount to know their length. So I still should have some hash map of letters. And then for then I go through the string less than length. After filling the letters map, I need to go through the letters add every how can I do it? I go through the letters. I add their amounts if they are even or odd. Even, yes. If they're even, I add it to yes, for I, then I less than object values of letters. I can var use in letters. I can go through the object like this, as I remember. Amount. It is amount of letters, and if amount is even, I just add it to result. If it's not even, if amount divided, reminder of dividing amount by 2 is 0, then result plus equal is amount. Else, if it's not even, I need to have a flag is added there, added false. Oh no, sorry. If amount in letters, I will add anyway result amount -1, and if added, then I will add it once. Result plus equal 1 is odd added true, and that's it. And then return result. And here I just fill in the letters map. If no letters si, then letters si is 0. Letters si increase by 1. That's it. Let's try it. Wrong answer. Result is not a number. I didn't get it. Let's console log amount. I guess here's the problem. Amount in letters. It's the key for in. I need to get how for in is enumerable string properties of an object, ignoring properties keyed by symbols. Const property. Aha, it's a key of an object. Examples. Give me more examples. Can we go through values? No. Okay, it's not a problem. In letters it will be letter amount, and that's it. What's problem with is added? It's misspelled. Let's try again. Accepted. Let's submit it. Yeah, for sure. Why is runtime so slow? I think it's because you can solve it with one-liner. Let's watch my previous solution. The same approach. Dict has own property. I have pretty complicated solution. I keep payers amount and reminder. I named it as rest, but it's reminder. And I increase pairs, then I calculate pairs plus pairs, rest plus rest. I didn't get it yet. Return pairs multiplied by 2 and rest. If we have rest, then 1 or 0. I don't understand my solution. Let's watch it again. I have dictionary with the letter as a key, and inside of it I put, if I don't put it yet, I put an object with two key with two fields, pairs amount and rest reminders amount. Initially we have 0 pairs of letters and rest of letters is 1. Okay, I see. If it's if I have 1 letter as rest, then I increase the pair by 1 and I set to 0 the rest. Otherwise, I just increase the set the rest to 1. Pretty complicated. After it, I iterate with, I create object values, array with object values, then reduce it to pairs and rest, and go through every pairs and rest object and accumulate pairs amount and rest amount. I guess it's incorrect approach because we can have more than one rest. Aha! Even if we have more than one rest, I add it up only one time. I see. Now I see. Let's check my other approach. Probably it's not my approach. I guess that I just copied it from someone's solution. It was beaten 100% of memory. Users by memory. Interesting. So it's simpler. Dict to the letter, previous value or 0 plus 1. And we add it to result every time if we have 2. Interesting. This runtime is not good because we make additional arithmetic operation for each iteration. For example, my first solution didn't make any addings. It makes it, sorry, but not a lot, probably. So, and in the result, as length more than result plus 1, otherwise is result. I don't understand. Why we have this why we have such comparison for I don't know. So we increase it by 1 in dictionary. If it equals to 2, we add 2 to result and set to 0. And we add it to the result each time when we have a pair. I see. And only if as length of the string equal to result and the string has only paired letters, then it means that we don't have any extra unpaired letters. So, but if the length of the string is more than result, it means that we have at least one unpaired letter, so we add it to result one time, any of it. Interesting approach. I only don't know if it's greedy algorithm or not. Probably in more complicated problems I can use it more precise, more explicit. I can see more explicit example of using greedy algorithm, but not here. So thanks everyone who watched it, and bye. Have a nice day.